In the previous lesson, we introduced the idea of sequences as discrete functions. So in this lesson, we're going to look at a specific type of sequence, which are called recursive sequences. I don't want to spoil what a recursive sequence is, but the name kind of tells you how it behaves. So let's look at one of the most famous recursive sequences. So the Fibonacci sequence. 1, 1, 2, 3, 5, 8. So you can go and kind of take a look and see what the pattern is. Take your time. It might not be obvious, but this pattern is very, very famous. Okay, so what's the pattern? Hopefully you can see that you could find sum of previous two terms to obtain next term. So 2, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5, 8. So the next term of the Fibonacci sequence is 13. So what makes the Fibonacci sequence a recursive sequence? Well, a recursive sequence, the way it behaves is a little interesting. You find the next term of the sequence by relying on your knowledge of the previous term or terms. And the Fibonacci sequence definitely follows that behavior. Like, I can't tell you what the next term, like, what is it? Let's see. I can't tell you what the 7th term is unless I know the value of the 6th term and the 5th term. For example, I can't tell you the 100th term until I know what the 99th and 98th term is of the Fibonacci sequence. Okay, so what makes the Fibonacci sequence a recursive sequence? Terms are defined using previous terms. So I'm going to generate the formula, the recursive formula, after we get some practice with some formulas. So we talked about explicit formulas, but this is a recursive formula. So let's take a look. This is our recursive formula. So they tell us that the first term is equal to 3, and that the nth term is equal to the previous term minus 2. Okay, so to find the nth term, I take the term previous to the nth term and then subtract it by 2. And of course, n is a natural number and n is greater than 1. So I did the math here. So to find the second term, it's the first term minus 2. Well, luckily I know what the first term is. 3 minus 1 is 2. So to find the third term, I'm going to take the second term and subtract by 2. Well, what's the second term? 1. So 1 minus 2 is negative 1. So now let's find the fourth term. The fourth term is the third term minus 2, right? The previous term is the third term. So luckily, I know what the third term is. Negative 1 minus 2, which is 3. So what are the first 4 terms of the sequence? Therefore, the first 4 terms, we're looking at 3, 1, negative 3. Those are the first 4 terms of this recursive sequence. Okay, and we found them by using the recursive formula. So here's a great question. What would happen if the first term was not given to the reader? We will be stuck, right? Without that piece of information, I can't find the second term. And without the second term, I can't find the third term. So hopefully you can see that it's very different from an explicit formula. Where with the explicit formula, I could tell you the 100th term pretty easily. I can find the value of any term right away, actually. Okay, so let's use this recursive formula here. We have the first term is negative 1. The nth term is equal to the previous term plus 2. Okay, n is a natural number, n is greater than 1. So when you write your own recursive formula, please include that. I know it's tedious, but it is necessary because this makes it a discrete function here. All right, so the second term is the first term plus 2. Luckily, I know what the first term is. It's -1, so -1 plus 2 is 1. The third term is the second term plus 2. And luckily, I know what the second term is. And lastly, we have to find the fourth term, which is the third term plus 2. And the third term is 3, so the fourth term is 5. So now I can tell what the first 4 terms are. -1, 1, 3, 5. And hopefully you could have seen this. Like you really didn't need to show all this work if you saw the pattern. If you take the previous term plus 2, so -1 plus 2 is 1, 1 plus 2 is 3, 3 plus 2 is 5. So you're really following like a linear pattern, like a linear relationship. Same could be said for the first example we did. Okay, but the subsequent examples we're going to do will be a little more complicated. But, you know, just to show ourselves how a recursive formula works, I showed you all my steps. All right, let's go back to our Fibonacci sequence here. So how would you write the recursive formula for a Fibonacci sequence? Well, not only do you have to give the reader the first term, you actually have to give the reader the second term as well, right? Because you need to find the sum of the previous 2 terms. So tell the first term and the second term, then they can find the third term. So the first term is 1, the second term is 1, and then I tell them that the nth term, or the general term, is equal to the sum of the previous 2 terms. So the previous 2 terms, the subscript will be n minus 1. That'll give you the term before the nth term, and n minus 2 will give you the 2 terms before the nth term. Okay, and then n is of course a natural number, and n is greater than 2. Okay, not n is greater than 1 because we gave the first 2 terms. We have to start the reader off with the first 2 terms, and then they can find the third, fourth, fifth, so forth and so on. All right, so let's build some more recursive formulas here. Now, before I do that, I do want to mention that its recursive formulas are a little tedious because if you want to find the value of the 100th term in the sequence, you need the value of the 99th term. And then you need the 98th term to find the 99th term. And you need the 97th term to find the 98th term, and so forth and so on. So it's a lot more tedious than an explicit formula. Right? Like I said before, you can find the value of any term you want with an explicit formula without doing very much work. All right. So determine a recursive formula for each sequence. So I did the first one here. So you take if you follow this pattern here, follow the sequence, you take the previous term and multiply it by -2. All right, awesome. Okay. Add 4, add 4, add 4. You know what? I don't think you need me to write some steps here, but I'll show it to you anyway. So the first term is 2. Let's start off the reader with that. So the second term is the first term plus 4, the previous term plus 4. And the third term, once again, previous term plus 4, previous term plus 4. So the recursive formula is, so the first term is 2. The general term is the previous term plus 4. N is a natural number. N is greater than 1. Okay, 3, 5, 8, 12. Wait a minute. So you're adding by 2, adding by 3, adding by 4. This one's not as obvious as the first 2. So you know what? Let's see if we can write something down and see a pattern here. So the first term is 3. The second term is the first term plus 2. The third term is the second term plus 3. The fourth term is the third term plus 4. Wait a minute. What we are adding by is exactly the same as the term number, right? 2, term number is 2. Add by 3, term number is 3. Add by 4, term number is 4. So I think we can use that pattern, right, to generate our recursive formula. So tell the reader the first term, very important. And then the general term is the previous term plus n. N is a natural number. N is greater than 1. Perfect. Okay, what about this one here? So, this doesn't follow like a linear relationship here. So you know what? Let's show some work and hopefully we can piece it together. So the 6 is first term plus 4, and the 12 is plus 6 here. Second term plus 6, previous term plus 6, and the fourth term is the previous term plus 8. All right, let's see. Oh, so now if you look at what you're adding, right, to find the second term here, we take the previous term, add by 4. To find the third term, you take the previous term, add by 6. And to find the fourth term, you take the previous term, add by 8. So what you're adding by is actually double of the term number. Oh, what a nice coincidence. That works out beautifully. We can use that relationship to generate the recursive formula. All right, last one here. All right, let's take a look. This is very similar to the relationship we saw at the beginning, right? So the first term is 2, the second term is 5, the third term is the second term plus the first term, and the fourth term is the third term plus the second term. So it's very similar to the Fibonacci sequence, right? It's not, but the idea of how to find the subsequent term or the general term is very similar. So the first term is equal to 2, the second term is equal to 5, the general term is equal to the sum of the 2 preceding terms. There you go. So hopefully you have a better understanding now of recursive sequences and how to find the recursive formula when you're given the recursive sequence. Okay, it might take some work, but just let's try to look for a pattern and see if it works.